students, welcome to Easy BTech. Today I am going to explain about differential equations. Before that, please like, share, subscribe Easy BTech channel. So differential equations. So what is nothing but differential equation? It's an equation involving derivatives of one or more dependent variables. Okay, one or more dependent variables with respect to one or more independent variables is called a differential equation. Okay students, so an equation involving derivatives of one or more dependent variables with respect to one or more independent variables is called a differential equation. Yeah, okay. The next one, types of differential equations. So types of differential equations. Types of differential equations. So okay students, so in general we have two types of differential equations. So there are two types of differential equations. Differential equations. Okay students, okay, they are, the number one is ordinary differential equations. Ordinary differential equations, and second one is partial differential equations. Second one is partial differential equations. Okay students, two types of differential equations. So the number one is the ordinary differential equations and number two is the partial differential equation. So what is nothing but ordinary differential equations? It's the definition of ordinary differential equations. Okay, the definition of ordinary differential equation is nothing but a differential equation is said to be ordinary differential equations if the existence of derivatives are ordinary. Okay, then a differential equation is said to be ordinary differential equation. Ordinary differential equation if the derivatives are ordinary. Okay students, ordinary. So for example dy by dx whole cubed minus dy by dx whole square plus 7y is equal to cos x is the one example. And one more example, d square y by dx square plus 5x into dy by dx whole square minus 6y is equal to. Both are the examples of ordinary differential equations. So the next equation, partial differential equation, that is partial differential equations. Yeah, the definition of partial differential equation. So a differential equation is said to be partial differential equation if the derivatives have reference to one or more independent variables. One or more independent variables. So it is the definition of partial differential equation. So ordinary differential equation means consisting ordinary derivatives. Partial differential equation means is said to be partial differential equation if the derivatives have reference to the one or more independent variables. So the example of a partial differential equation, the example, dou square y by dou x square is equal to 1 by c square dou square y by dou t square. And one more example, dou square u by dou x square is equal to 1 by c square dou y by dou t, like this. So two types of DEs are there, ordinary DE and partial DE. Ordinary DE means consisting ordinary derivatives. Partial DE means consisting the partial derivatives with have reference to the two or more independent variables. Okay, and next definition is nothing but here order and degree of a differential equation. Order and degree of a differential equation. Okay students, so first of all about order of a differential equation. So at first order, yeah, what is nothing but the order of a differential equation. So a differential equation is said to be differential equation is said to be an n order or an order of n if the nth derivative is the is the highest derivative, nth derivative is the highest derivative in the equation. Nth derivative is the highest derivative is the equation. So nth derivative is the highest derivative. So for example, if x square plus 1 and dy by dx plus 2xy is equal to x square, and second example, x square into d square y by dx square minus 2x minus 1 dy by dx and plus x minus 1 into y is equal to e power x. These two differential equations are there here, and in the first example dy by dx is the highest derivative here. Dy by dx is the highest derivative. So hence the order of this equation is equal to 1 only. Coming to the second example, so here d square y by dx square is the highest derivative, in this equation. So hence the order is equal to 2 here. Okay, and the next one, degree of a differential equation. So the next one is the definition of degree. Yeah, okay, degree. Yeah, degree of a differential equation. The degree of a differential equation, is the highest degree of the highest derivative. highest degree of the highest derivative. Okay, highest derivative out of the highest derivative which occurs the differential equation has been made free from fractions. Okay students, so what is the definition of degree here? So degree is nothing but highest degree of the highest derivative. Okay, order is nothing but highest derivative, degree is nothing but highest degree of the highest derivative only. So for example, now I am writing one example here. Example, a square d square y by dx square and whole square is equal to 1 plus dy by dx whole square and again whole cube. So observe in this differential equation, the highest derivative is d square y by dx square, and highest order of highest derivative, then that is, so highest derivative is d square y by dx square, and its order is nothing but 2 here. So then the degree of this example is nothing but 2 only. Okay students, this is nothing but the order and degree of a differential equation. Now coming to the solutions of differential equations. Okay, an equation is of the form, here. So an equation is of the form dy by dx is equal to f of x comma y. Okay students, dy by dx is equal to f of x comma y is called differential equation of first order, differential equations of first order and first degree, Okay, so we study the following methods. Okay, the following methods to solve first degree and first order differential equations. That means dy by dx is equal to f of x comma y. So what are the methods here? That means the first one is exact equations, and second one is linear differential equations, and third one is Bernoulli's equations. So what are the methods students here? Exact equations, linear differential equations, third one is the Bernoulli's equation. So at first about exact equations, the first one is exact equations. Yeah, what is nothing but exact equation and what are the evaluation procedure about exact equation? Yeah, First one about the standard form of an exact equation, the solving procedure of an exact equation, how to get the general solution of an exact equation. So the exact equation means m dx plus n dy is equal to 0 is the standard form of an exact equation. Okay, the standard form of an exact equation. M dx plus n dy is the standard form of an exact equation. Yeah, okay. Then on the working rule for the solving of exact equation. So the working rule is nothing but compare the given equation with m dx plus n dy is equal to 0. Okay, this is the first step. And second one, find the values of m and n. And third one, this is exactness condition. So that exactness condition is nothing but dou m by dou y is equal to dou n by dou x. And the fourth one, for general solution, so integral m dx and plus integral n dy is equal to c. And one important thing here, have to remember here, integration is free from x. This integration is free from x. Yeah, students. So what is nothing but exact equation? Students, exact equation is nothing but here. So if the given equation in this form, that is m dx plus n dy is equal to 0 form, satisfying this condition. What is that condition? Dou m by dou y is equal to dou n by dou x. Then the standard form of this equation is said to be an exact equation. That is the first step, students. So how can you find out whether the given equation is an exact or not? Means the first step is changing the given differential equation into the standard form. So what is the standard form? Standard form is m dx plus n dy is equal to 0. If the given equation is in the standard form of an exact equation, and second step is writing the values of m and n. So writing the values of m and n. So after writing the m and values, verifying the exactness condition here. So what is the exactness condition here? So exactness condition is dou m by dou y is equal to dou n by dou x. Okay, dou m by dou y is equal to dou n by dou x. So if the standard form of differential equation satisfying this condition, then we can say that the given equation is an exact equation. So after exact equation, to find the general solution here, general solution is doing the integration of m with respect to x and n with respect to y, then integral m dx plus integral n dy. So when you are doing integration with respect to y here, this n term is free from x here. Okay, so what is the meaning of free from x means here? So when you are doing integration of n with respect to y, then if x variable is there in n term, then no need to do the integration of that particular term. That is the meaning of free from x. I am writing here. The first step is the standard form, verifying the standard form here about exact equation. So what is the standard form? m dx plus n dy is equal to 0. And second step is finding the values of m and n, at the same time verifying the exactness condition. Exactness condition is dou m by dou y is equal to dou n by dou x. So if it is exact equation, then finding the general solution. So general solution is integral m dx plus integral n dy is equal to c. So while you are doing integration with respect to n here, the second integration is free from x here. This is the main about the integral, about exact equation here students. Yeah, okay. The next one, the corresponding problem related to this step. Okay, so here n dy. Yeah, okay. So now the problem about exact equation. Yeah, solve the first question here. Solve e power y plus 1 into cos x dx and plus e power y into sin x dy is equal to 0. Okay students, it is the first question. So okay, the solution. So at first you have to verify that whether the given equation is in standard form or not. Okay, so what is the standard form? Standard form is mdx plus ndy. So what is the solving procedures method students? At first step is standard form. So the standard form is mdx plus ndy is equal to 0. So verify the given equation. So it is m dx and it is n dy. So now assume it is equation 1. Then equation 1 is in the form of, equation 1 is in the form of, what is the form student? mdx plus ndy is equal to 0. And second step is writing the values of m and n at the same time verifying exactness condition, dou m by dou y and dou n by dou x. So I am writing the m value here. M is e power y plus 1 into cos x and the value of n is e power y sin x. Okay, so before finding dou m by dou y and dou n by dou x, multiply with cos x here, e power y cos x and plus cos x, and n is e power y and sin x. Yeah, the first condition is dou m by dou y. So we know how to do the partial differentiating here. Dou m by dou y is there here students, then e power y is common. E power y have to do here, then cos x becomes as a common here because we are doing partial differentiating with respect to y here. Yeah, okay, cos x common, then dou by dou y of e power y, and here there is no y, that means cos x is a constant and for one differentiation is 0. Then cos x into e power y differentiation is e power y only. Then coming to the dou n by dou x value here. So here e power y common and dou by dou x of sin x because partial differentiating with respect to x is there here. Then e power y and sin x differentiation is cos x here. Okay, so observe these two values students here, e power y cos x, e power y cos x. Then here dou m by dou y is equal to dou n by dou x. It is nothing but the exactness condition students. If any standard form equation satisfying this condition, so hence so we can say that here equation 1 is an exact equation. Okay students, exact equation. So how can we say that it is an exact equation? Because it's satisfying the exactness condition. What is that exactness condition? Exactness condition is dou m by dou y is equal to dou n by dou x. Okay, after exactness condition have to find out the general solution of the problem. So general solution. So what is the formula for general solution? Integral m dx plus integral n dy is equal to c. So one important condition is there here, that is free from x. Okay, so now I am substituting the values here, that is integral. What is the value of m student? M is e power y cos x and plus cos x dx, m value, and plus n is e power y sin x dy is equal to c here. So now I am writing that condition. What is that condition? Free from x. Okay, so with respect to x, integration is as usual integration. Okay, with respect to y only we are applying this condition, that is free from x condition here. Yeah, now I am dividing the integration e power y cos x dx and integral cos x dx and integral e power y sin x dy is equal to c, and it is free from x. Okay, now I am doing the integration. So here with respect to x is their integration, then e power y common, then cos x and dx, and here also cos x dx, and here e power y sin x dy c, and it is free from x. It is the main condition here. So now I am doing the integration. Okay, integration. So e power y integration cos is nothing but sin x and plus again sin x, and see here students. So free from. So free from x means, listen carefully. So when you are doing integration with respect to y, if x term is there, then no need to do the integration. Then total integrand value becomes as a 0 and is equal to c. Okay students, then if you are making sin x as a common here, then sin x into e power y plus 1 is equal to c is the final answer students. Thank you students.